Welcome everybody. We are expected to integrate this. Now, by normal substitution, it's not easy to integrate this. So what we have to do is we have to perform some manipulation. So for the denominator, I wish to take e raised to the power of bx out. So if I were to do that, I would get a 1 over e raised to the power of bx, positive 1 here, and the numerator just has 1 times dx. Now this can be further rewritten as dx over e raised to the power of bx times, I'm moving this to the numerator, so this is going to be e raised to the power of negative bx, positive 1. Now of course the limits are 0 to infinity, 0 to infinity. Now what I wish to do is I want to get rid of this e raised to the power of bx. So I will rewrite 1 as e raised to the power of bx negative negative bx. Bx negative bx will get cancelled out, giving me e raised to the power of 0. E raised to the power of 0 is nothing but 1, right? Okay, so let me do that. This is e raised to the power of bx negative bx times dx divided by e raised to the power of bx times e raised to the power of negative bx positive 1. Now a raised to the power of m negative n can be rewritten as a raised to the power of m times a raised to the power of negative n. So this can be rewritten as, of course the limits are 0 to infinity, 0 to infinity e raised to the power of bx times e raised to the power of negative bx times dx divided by e raised to the power of bx times, I'm going to rewrite this as 1 positive e raised to the power of negative bx. Now e raised to the power of bx, e raised to the power of bx goes off, giving me integral 0 to infinity e raised to the power of negative bx times dx divided by 1 positive e raised to the power of negative bx. Now let me take 1 positive e raised to the power of negative bx to be a sum u. I differentiate 1, I get 0. I differentiate this, I get e raised to the power of negative bx. The coefficient of x is negative b, and the differentiation will have to be added. The operator dx will have to be added there. So this is going to be equal to du. So in place of du, I can substitute e, or I would say in place of e raised to the power of negative bx times dx, I can substitute du over negative b, right? I need to push this b down. So in place of this e raised to the power of negative bx times dx, this would be the substitution. So integral du over 1 over b with a negative sign divided by 1 positive e raised to the power of negative bx, that's going to be u. Now but we need to set the limits. I'm going to use a space here. So when x is equal to 0, what happens here? When x is equal to 0, e raised to the power of 0, that's 1. So I get u is equal to 2. Next, when x is equal to infinity, what happens here when you put infinity? You get 0 there. So this is going to be 2 to 1. Excuse me. Now if I change the limits, the negative sign goes off, so it's going to be 1 over b, limits of 1 to 2 du over u. I integrate this, I get 1 over b ln u, limits of 1 to 2. I substitute the upper limit, I get ln 2. I substitute the lower limit, I get ln 1. But ln 1 is goes off, right? So this is going to be 1 over b times ln of 2. So this is the solution to this beautiful integral. Okay, thank you everybody. Please like, share and subscribe.